Welcome back. Let's take a look at how to sketch the graph of a piecewise function. And we're looking at f of x equals x minus 1 if x is less than 1, or x squared if x is greater than 1. So if I'm doing these by hand, what I like to do is just look at the two separate graphs as a single piece. So I'm going to start off first with understanding what it means to graph just y equals x minus 1. So you might recognize that as a linear function, and the slope is positive 1 over 1, and the y-intercept is negative 1. So you can start off by looking at your coordinate system and maybe begin by plotting the y-intercept, which is at negative 1, and use the slope to go. It would be up 1 and right 1. So it gets the next point on the line, up 1, right 1. You can keep going if you want accuracy. Maybe you have a straight edge. Now, if I were just looking at it and this were not a piecewise function, we would talk about connecting the dots or the points that we've plotted, and we would be good to go. However, since it's a piecewise function, we have to pay attention to its domain. And in this case, it's telling us that we only plot this line if x is less than 1. So what I like to do is understand, I mark on the x-axis where x is equal to positive 1. And what that does for us is it creates kind of an invisible cut in the function. And you're either going to take the left side or the left piece of the graph or the right side. And if you're trying to understand what side to take, if we're looking at all values that are less than 1, that would be all of these x values. Let's see if I can highlight that instead. All of the x values to the left. So that means the corresponding graph, or the piece that we would take, would be this lower piece right here. So what I like to do is I have an eraser nearby, and it's not going to work so well because I think I connected everything in one piece, but you will see me erase off this piece that I do not need. So let me kind of modify that for you. Reminding ourselves. So again, if we are taking all the values to the left of positive 1, if I were to graph my graph again, I'd start at negative 1, up 1 over 1. I also want to point out that because we have the strictly less than, we would have ourselves an open circle on our graph. So let me see if I can kind of lightly do this. There's my line. And technically this is the other piece. But remember, we do not need that piece because that's not part of the domain, so we can erase it. But we do have to be careful that at the part where the graph hits x equals 1, we're going to leave ourselves an open circle. I've exaggerated that quite a bit. So now I'll do the same thing with f of x equals x squared. And again, you see me consider this as y equals x squared. And I realize that that is going to be a parabola. It's a very nice one, the parent graph. We can kind of go with ordered pairs if this helps. At 0, 0, we have the vertex. At 1, 1, we have one piece. Negative 1, positive 1, we have another piece. And 2, if we square 2, we're going to get 4. So we have 2 comma 4. And in symmetry, we can go negative 2, we'll also get positive 4. And that's pretty good accuracy for what we're dealing with right here. Now, if we were to connect all the points, this would be if we were not looking at this in terms of a piecewise function. So you would kind of see this U shape. I'm a little shaky there. Try that again. I'm a bit of a perfectionist. I try. So that would be the full graph. But we have to be careful again, because we have to realize that if we're trying to deal with the domain, we're only going to take the portion of the graph for which x is greater than 1. So that's the portion of the graph to the right of the positive 1. So that would mean I would take my trusty eraser and I'd erase all of the pieces. Not all of the pieces, but all of the pieces such that we would have any values that were less than 1. Trying to get a little bit more preciseness. I'm going to erase that point there. There we go. So what you see, we have that piece of the parabola for all the x values that are greater than 1. And I just want to make sure there's that endpoint. That's where that x is equal to positive 1. You will also notice again, it is a strictly greater than symbol. So again, we would have an open circle right where the function hits. So I will exaggerate that again, kind of have like a hole in the function. So if I can, I'll kind of clean this up a bit. And we'll have pretty much our function ready to go. I know those open circles are a bit exaggerated, so let me see if I can help with that. I'll make it a little bit more precise. There we go. And then we have that part of the parabola right here at x equals 1. So this would be the way to sketch this by hand. If you're looking for the domain, what we would do for ourselves is just read from left to right. We'd be looking at starting on the x-axis and looking for a picture above, below, or on. Looks like we have a picture below. So the domain would start at -infinity. And if we keep traveling on the x-axis, we keep seeing we have values, corresponding values of y for every corresponding value of x. However, at x equals 1, neither of the functions have a corresponding y value. It's undefined. So we would stop at positive 1. But right after you hit positive 1, you're going to start to see you hit the rest of the graph. That's the other piece of the function. So whenever you have a gap, we would use union. And we'll take this out from 1. And it appears to be positive infinity. So that's how we sketch a piecewise function by hand. I like to consider the full pieces, and then I do the erasing. If you prefer, you could look at this on your TI. However, kind of note that your TI will never give you the precise locations of where the holes would be or the open circles would be. You'd have to kind of determine that based on your domain. So feel free to explore that. But for the most part, we do this by hand. We do pretty well for ourselves. So I hope this helps. I'll see you in the next example.